So this is the post-test review for covalent bonding. And so let's get right into it here. We have to first of all determine how many valence electrons there are in a molecule like this, H2. And so remember, hydrogen has 1 and 1, so the total number of valence electrons is 2. So in order to show that, the only thing hydrogen can do is just simply bond with another atom of all types with just 2 electrons like that. Of course, the alternate way to put it would be with one long dash like this. And so that's the correct answer for hydrogen. Now for fluorine, each one of these has 7 valence electrons. So the total here was 14 valence electrons. And obviously it's going to want to make a bond with the other fluorine, and it does that by sharing 1 electron with the other fluorine, bringing its number from 7 up to 8. There you go. You could put a dash here if you want, substitute those two dots. Okay, so for oxygen, oxygen has 6. Since there are 2 of them, we should have 12 valence electrons in this case. So when you think about it, each of these oxygens is going to need to go up by 2 to get to 8. So we're going to see what's called the double bond here. And you have to put the extra electrons around the outside like this. Again, another way to write this would be 2 long dashes. And then, of course, make sure you put the 4 electrons on the outside of the oxygen, which are unshared, like that. Perfect. All right, here we have nitrogen. Nitrogen has 5 valence electrons, so between the 2 nitrogens we have 10. Nitrogen is going to require what's called a triple bond, 3 dashes, that's 6 dots, 6 electrons. And the only place to put the other ones are somewhere else on the nitrogen besides the bonds. Double checking our answer, it's 10 valences. 2, 4, 6, 8, 10. So every time you see a hydrogen, just make sure you just bond it like that with 2 valence electrons. So this one should have 8 total, 7 and 1. So the extra ones for the chlorine, the other 7, you just have to put them around the outside like that. And this is exactly the same type of thing as hydrogen chloride, hydrogen bromide. These are both halogens. They bond exactly the same way. Oh, and this is also 8 valence electrons. Okay, the next 2 coming up. This is water, H2O. So it has 6, 7, 8 valence electrons total. So remember, all you get to do with the hydrogen is just bond it with 2 dots, which is equal to 1 dash. And so the other 4 valence electrons on oxygen, you have to put somewhere on the oxygen. And that's the correct dot structure for water. Here we have sulfur, which is 6, and then 7 and 8 valence electrons. It's really the same as this one. Sulfur is in the same vertical column as is oxygen, so there's really no difference between this one and the other one. It's just sulfur instead of oxygen. Here nitrogen has 5 valence electrons and each hydrogen has 1. So here we have 8. So what I would do is I would bond each of the electrons of the hydrogen with 1 of those of the nitrogen. So that's taking up 3 of the nitrogens. The other 2 need to go somewhere on the nitrogen apart from the bonding. Okay, here this is CH4, methane. Carbon has 4, 5, 6, 7, 8. So here we have 8 again. And just simply, you can put dashes between these, and that's finished. 4 of the valence electrons of the carbon are being shared, 1 with each of the hydrogens. This is a lot similar to that one. The only difference being instead of 1 valence electron in the hydrogen, here we have 7 in the chlorine. So we just have to put the other 6 on the outside of each chlorine like this. Okay, so here we have 28 and 4, 32 valence electrons total. So here we have 7 times 3 is 21, plus 5 is 26. This one is very similar to the one above it. The chlorine, of course, having 7 valence electrons just means all those other 6 that are not involved with bonding are going on the outside, just like they did here. And then we have to bring in 1 of the valence electrons from the chlorine and 1 from the nitrogen, and the other 2 from the nitrogen would go on top like that. Okay, then the final 3 for the test. Here we have 6 and 4 and 6, so that's 10 and 6. We have 16 total here, valence electrons. This is a lot like CO2. I'm going to put all 4 of the electrons from the carbon in the bond, and I'm going to put 2 from each sulfur, and then sulfur has 6, so I have to put the other 4 on the outside, like that. That's a pretty good representation of it there. If you want to use dashes, remember, you just have to make sure that you take away the dots completely and put in all the electrons, including the ones that are unshared here, like that. Okay, so hydrogen only gets 1 bond, but so does the chlorines. They get 1 bond with the carbon. The only difference is you have to put these valence electrons on the outside. They're kind of faded here, but kind of going on. So this one has 7 times 3 is 21, plus 4 is 25, plus 1 is 26. Finally, we have this. That's 5 valence electrons and 4 and 1 for a total of 10 valence electrons. Hydrogen only can make 1 bond. That's all it can do. And so now nitrogen needs to go up by 3, and carbon needs to also go up by 3 from where it was. So I'm going to make this into a triple bond, and then the extra 2 from the nitrogen go on the outside. So in the final analysis, it could look like this. That is a dash, triple bond, and 2 dots. There we go. That's the presentation for this test on covalent bonding.